In college algebra, we started rational functions. So to start out, we have that equation right there, or function. Let's look at it on the calculator. So it was 1 over x. And there it is. The weird thing is this looks like multiple graphs, but this is one graph. And the reason why it's so weird, why it looks like multiple graphs, is all because of the x being in the denominator, right there. So a rational function, that's when you have x in the denominator, and it changes things. It limits what you're allowed to plug in. Because if I was to plug in 0, it just wouldn't work. It's undefined. So look at the x-axis at 0. Notice the graph skips that spot. It's getting close to it, close to it, close to it, and then it jumps to up here. So it never actually hits the x value of 0. So at that spot, at the origin, there's actually an imaginary line that is the y-axis. So this right here is a line that the graph cannot touch, that green dotted line. There's another one right here, which is the x-axis. For this problem, it always changes, depends on what's typed. But for the same reason that, well actually it's not the same reason, since x can't be 0, the y value will never equal 0, because there's no number you could plug in for x that will give you 0 for y, so that's why it jumps both of those spots. All right, so let's go to the notes. Let's do a quick sketch of the graph. It goes through 1, 1, and it goes through -1, -1. Those are the only 2 points I really care about right now. And let's do a quick sketch of the graph. So it looks something like that. And something like that. All right. And the domain, I already talked through it, is any number except 0. So you could write all real numbers except 0. You can just write what I just wrote right there. Maybe write a reason. I won't grade this, but for your notes, because we cannot divide by 0. Now what I typed below this is a little confusing, at least with notation, because in the math textbook it writes it like this: as x approaches infinity, what is y approaching? That's how it writes it. So what I tried to do, right above where I just wrote that, tried to write it in words. What is the graph getting really close to on the x-axis, but never actually touches? And that is 0. So let me change colors so you can follow the color. So I'm going to start at this green, now purple dot, and the graph is moving. It's getting bigger and bigger and bigger and bigger and bigger and bigger. Like I'm looking at the x-axis. And this goes forever. As x approaches infinity, it's going to get closer and closer to that x-axis, which is 0. Same idea over here at this green dot. As x gets tiny, it's going smaller, 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 smaller. It's approaching the x-axis, or y equals 0. So you can write that 2 ways. As x approaches negative infinity, y is approaching 0. It's a really confusing idea. Another confusing thing is, what if we flip the question and we say, as x approaches 0 from the left? That negative sign above the 0 means left. So as x approaches 0 from the left, okay, now let me change colors. Let's look at blue. So I'm sitting right here on the graph, and I'm going to move towards 0 on the x-axis. So the blue line is moving to the right, and all of a sudden it shoots down. That means y is approaching negative infinity. What if I approach 0 from the right? Whoops, that's on the line below that. So from the right means plus. All right, so let's go back to blue and look for the blue dot on the far right of the graph. So I'm hanging out right here, and I'm going to approach 0 from this side of the graph. So I'm approaching 0, approaching 0, approaching 0, and all of a sudden it shoots up. It's going to go to infinity. So two different behaviors right there on either side of 0. It's either, the graph is either going down on the left or it's going up. All right? Let's look at one more example. This is a very confusing topic, so we're going to practice it a lot. In this graph, if we were to type it in, we would see the graph scoot over 3 units to the right. And our new imaginary line is at 3. Whoops, I just messed up this board there. Okay, our new imaginary line is at 3. And that's because if I plug in 3, I get 0. X minus 3 equal to 0. This is what the graph cannot equal. It just won't work. If I plug in 3, I get 0 in the denominator. Domain is any number but positive 3. We have a point at 4, 1. If we were to type this in, it's always over 1, up 1. And then left 1, down 1 from that vertical imaginary line. So our graph looks similar, but it's just 3 units to the right. So it does something like this. And something like that. That's a bad arrow. Let me fix that. A little better. All right. So we did a graph. It can't equal 3. That's actually, that dotted line is actually called an asymptote, that imaginary line it can't cross. And there's another imaginary line on the x-axis. So that red line, it will never cross that line, or touch that line, I should say. It jumps over it, but it won't touch it. All right, we'll stop there. Have a great day. Bye.